So I wanted to show about this number line and about using it to help figure out where the reactants and products are. So there are three different mixtures we're going to look at and see how the equilibrium falls for all of them. So this first one, you can see by color, it contains just the reactants and nothing else. So that's why it's sitting all the way over here on this side. And if we had any products, they would be yellow and green. So we aren't there. And then on this graph, I have this marked with a 1. This is when like all the reactants and products would all be the same, because then it would be just they'd all cancel each other out and that'd all be just 1. So the real equilibrium value is actually here. And since it's less than 1, that means that we are going to have more reactants at the equilibrium. And this is actually what happens. If you look at this picture right here, you can see that if I kind of put them near each other, you can see that the amount of red has gone down and blue has gone down, and then it's been changed into green and yellow. And it's just slightly on the sizing of it, but they should be right about at the same height right there. And so that's good. That means the reaction has started going, but it's not going past that point. So instead of coming all the way over here to just yellow and green products, it ends up lying like right there on that point. So that's the reaction composition if you start with all reactants. And then let's look and see what happens if you start with all products. So in a way, this is kind of like thinking of the reaction backwards, but if you just have a mixture of the two things on the right, and remember there's your K value right here, there's your K, but you just have the two things on the right, that's still going to form an equilibrium, and they're going to shift in to the left position. And this is how this one ends up looking. So when I'm going to put them close to each other, you'll remember the equilibrium for the reaction, it's always going to be what it wants to be. And in this case, it's still that same number. We just had a higher quantity of the products to begin with, so we end up with a higher equilibrium total quantity. But you can notice we have more reactants, the red and the blue, than products. And so that falls there. And those ratios are going to be the same, whether we start with a little bit of reactants or a whole lot of products. We just let it sit there. They're going to eventually establish that equilibrium. And then finally, what happens if we have like some crazy mixture of them? So here's this mixture. We're not actually over there at that point yet, but here's that mixture. It's still got a whole lot of reactants and just a little product. So maybe I would put it like maybe like right there. And then here's what happens to this one. Again, it still goes back to this point, and this is just a slight sizing thing. Let me get them sized back up to match. There you go. That's close. And then again, that same ratio. Now looky here, this is a little bit different. If you look at that reactant ratio, do you notice how there is a little bit more red than there is blue, but together there's still more reactants than there are products. And the way it happens is when you multiply them times each other as being in the denominator, that one works out so that we still have that same K value. So all three things together, you can see they all came together, and regardless of how they started, they all ended at the same ratio of reactants and products.